Bob Nagy here, AB5N, with yet another equipment review. This time I'm going to say this may be your next radio. Strange looking, isn't it? Well, what is it? It is a 10 through 80 CW and sideband QRP radio, 10 watts, out of India. Ashar Farhan, VU2 ESC, has spearheaded this thing on hfsignals.com. Check out the site. It is just over $100 delivered, and it is made by a group of women in a cooperative in India. The entire circuit board is sent completely assembled. You're just going to put on the volume controls, connectors, put it in some kind of enclosure. Shielding is not absolutely necessary. And boy, this little stinker works. So let's take a little look inside this radio. It's an up-conversion double superhet design with 10 through 80 meter CW sideband, built-in CW gear, and it's designed elegantly and efficiently. I built mine in a 1/4 inch plywood box, but you can use any kind of material you'd like to work with. Let's take a look at the basic circuit architecture. I'd like to mention first that it uses a pair of IRF 510 inexpensive FETs as the finals, and the bias adjustments are those two blue trim pots on the top. Bias is set at the factory. The radio's brain is the Arduino Nano, a very inexpensive microcontroller. It's mated to a 2-line LCD display and an SI5351 frequency generator to form what's called the Raduino. The SI5351 is an oscillator chip which has 3 outputs and uses a 25 MHz crystal, which is subdivided down to the individual frequencies. Lots of people use the little board plus an Arduino and a display to make their own versions of the Raduino. The Ubitx is shipped with a 2-line 16-character LCD display, but you can replace it with a blue or black and white display. They're very inexpensive. The Ubitx uses the Raduino with an up-conversion double superhet scheme with 45 MHz first IF and 12 MHz second IF. To keep costs down, 8 computer crystals are used in the second IF to form a 2.4 kHz crystal filter, which is used on sideband NCW. The front end uses a 30 MHz low-pass filter, which keeps out FM broadcast stations. The first mixer is a double balanced diode mixer using a pair of BAT45 SL diodes. They're already matched, and there's no RF amp required because there is already adequate sensitivity at this point, and this does not compromise the intercept point. 4 IF amplifiers were used, and these are a novel transformerless design which have a gain of 16 dB each and IP3s of plus 20 dB. In the first 45 MHz IF, a 15 kHz roofing filter is installed. A TDA2822 audio amplifier was chosen instead of the generic LM386 because it's quieter and only one of its 2 sections are used. It makes the other section available for hackers in case you'd like to add an AGC to the system. Yep, there's no AGC. Lots of generic 2N3904s are used in this radio. In the transmitter circuit, they're used in pure Class A operation. 4 of them are used as push-pull drivers to the final section. After the finals, there's 4 harmonic filters used to keep the signal clean. And yes, you don't have to wind any of those toroids. These are all pre-wound and mounted on the board. Once you get your radio board into a box and the connectors connected, you're going to need to load some firmware, and you have some options here. The little Arduino has a USB connector on the side, and this board's mounted in back of the display. You'll be hooking up your PC here to load up the firmware. And you've got options here. Of course, it comes with a generic firmware, which will get you up and started, but amateurs have been improving on this, and the 2 most popular alternate firmwares for the unit are the KC8CDC by Ian and the W4UB W2CTX software by Jim and Ron. That's what I use, and I'm going to be showing you. Please note that these 2 guys are producing an upgrade Raduino board for this unit that gives you CAT control and other great features. Now, once you've picked your alternative software, which is what I suggest, you'll need to program it into the Arduino or the Raduino, and you'll need to get the Arduino program, which is called its IDE. This compiles the code and sends it to the Arduino. Now, this is simpler than programming memories into most radios with software, so don't be afraid to do this if you haven't done it. Go get the software from Arduino CC. It's free. Install it. Download the new firmware you want from one of these guys I previously mentioned, or a new one, and click on that firmware's icon, and it'll open up the Arduino programming program automatically. Then you just select Compile and Send, and it sends it up to the Arduino. But you do this with the radio turned off and your USB cable plugged into the Arduino. When it says it's done uploading, just unplug the cable from the Arduino, turn the radio on and off, and you're ready to go. If you use the W4UB W2CTX firmware upgrade, like I did, and I suggest, that's one I liked, go ahead and do this calibration procedure. This is the correct way to do it. It's not difficult at all. Hit the pause button on this video, take a picture of it with your camera or phone or whatever, and just follow this procedure and you'll be ready to go in just a few minutes. And here's what it looks like to get into those menus. I added an extra push button in tandem with the main tuning dial's push-in feature. This makes it easier. You hold it in, power it up, and you hold it till you see the alignment menu and then rotate that dial. You go through the 3 settings there. And the first one you're going to use is BFO. Now let's get to the fun part, the Ubitx in operation.
Patience, and he will stand by and wait. You mixed up a little bit, with the time change. That mixed things up there. Well, I have not been mobile for probably 6 or 7 years. I will let you wrap it up, Jerry, but you found a real live, unfrozen North Dakota ham. By golly, for sure you bet.
The radio even comes with a little condenser element and a micro switch to make your own little microphone with a little bit of hot glue. And it works. Well, there you go, the Ubitx 10 through 80 CW sideband transceiver kit from India. It comes with all the parts you need to make the item except for the box. So you can use any kind of material you want for that. I did add an inline fuse holder, I would suggest that, and upgraded to a PL259 type of connector on the back rather than the BNC. You do need a couple of knobs for the front. Look in the junk box. Also, the display just pops out of its connector and you can put any kind of flavor you want in there as far as 2-line, 16-character displays. They're all over the net. I ordered a white on black one for $3. It should be coming in soon. So I can't really think of a lot of things in amateur radio you could have this much fun with for $100. Of course, 2 thumbs up for this interesting radio from India. And do remember, when you order it, things from India come on Indian Standard Time. So be patient. Until next time, take care.
So as we mentioned, this is a basic kit. Essentially, you get the main board, the receiver. The first IF is at 45 megahertz, and it has a 15 kilohertz roofing filter. The second IF is at 12 megahertz, and it actually has a crystal filter, a 6-pole crystal filter. In the video, Bob mentioned that it uses crystals that are very standard, like a computer motherboard type crystals. And that was a very clever way to do it. So I found that the receiver is very sensitive, and usually I can hear just stages are actually common 3904 transistors. They cost about 15 cents each. And I never knew, I've always used them for either audio or switching applications. I never knew that they could be used in the RF world. So that was very clever. The finals, which are these RFS 510s, are actually power supply switching transistors. And they work very well. The shortcoming of this approach, however, is the output falls off as a function of frequency. So on 80 meters, I can see 15 watts almost. on my watt meter. By the time I'm up to 10 meters, the power output will fall down to about 2 watts. So that's an issue. Many individuals have come out with ways to resolve some of these shortcomings. And they're known design issues. It's not as if this came to light. I mean, this is what the radio does. And I think if you're going to buy this radio, you really have to understand the limitations. Excuse me. And they're written up well, and they're known. One of the issues that was mentioned by Bob Nagy as well, there's 2 of them. One is the AGC, the lack thereof. And that was very annoying because you have your volume up, listening to a weaker station, and a local station comes and will literally blow you right out of your chair. I don't know if you guys have ever fooled around with your HF radios by playing with your AGC attack. Okay. And you can actually turn it off. You lose your S meter, but you can turn it off, and you can experience some of those unpleasantries. The other thing this version did, this is a version 3, they're up to version 5. It had a very annoying click when you went from transmit to receive and back. So they've taken care of that. I installed a little board that fixed it because there's a lot of support from individuals who make these fixes available at a very low cost. I also have an AGC in this unit here, which is the one that I built in the cooking tin. So this one is pretty squared away. It's tailored to my needs with several improvements. There's more things I'm going to do to it, but I'm going to get through this first. Next slide. Okay, I think I covered this. The receiver, no AGC. There's also no RF gain control. That hasn't been a problem for me. Okay, one thing about the audio stage, he mentioned it uses an integrated circuit IC, and I found it can easily be overloaded and generate a lot of distortion when you turn up the volume control at higher levels. Another shortcoming, but easy to work around. Next slide. Okay, so on the transmitter, this slide again addresses the fact that power falls off as a function of frequency. And the transmitter design is very clever in the way it uses components or stages of the receiver. You can go to the next slide.
Can you bring your mic back? Bring your mic back.
Sorry, Tom. Next slide. Okay, we talked about the Arduino, and it's an Arduino with the display and the clock function. And this combination is really powerful because firmware drives this radio and tailors it. And when I first loaded it with the supplied firmware, I found that the radio was not a lot of fun to use. I had troubles with the fact that the calibration was off, and even though I followed the alignment procedure, I had difficulty getting the radio on frequency until I did some other techniques, and that involved the third-party software that was free. So they're still modifying the software, and improvements keep coming out. One of the latest things that have caught on are touch screens and color touch displays. They're really inexpensive. I bought one for like $20. It's 2.8 inches, and I'm going to be installing that. I was really involved with this, and then for about 6 months I got into some other projects, and giving this presentation kind of got me reinterested in it. So I'll be doing that modification. I'm just hoping that a 2.8-inch screen is going to be reasonable enough to use for touch. But that makes things a lot easier. Also, with the AGC, I'll have an S-meter function. Okay. Let's go to the next one. I'm not going to say much about this slide. This is a wire-up diagram. I put it in there just to show you an example of some of the online documentation. Basically, there's no documentation with this radio when you get it other than a parts list. It's up to you to go to the websites. It's not hard. It's not hard to find. And if anybody's interested, I'll be glad to help. In fact, the last slide in this presentation has links that can actually take you to all of the important sites and answer all your questions. There's probably at least 10,000 users of this radio now. So it has a lot of support. Next slide. This is an example of various enclosures. I brought this one, which is in the slide. This is the enclosure supplied by an Indian company, and this particular unit was donated to the club by someone who bought everything and decided he didn't want to build it. And I'll say one thing about this enclosure. It has some alignment problems. Everything was painted. I had to grind off a lot of paint. So all of the 4 components of the chassis actually were electrically connected. I personally am I'm not enamored of this case. I wouldn't buy it. What I think I'm going to do is ultimately migrate from this cookie tin to a box, a watertight box like that. And that, I think, is a much better approach for the field. This works great on a desk at home, but I think that's where I'm going to go. There's a lot of cases you can buy on the order of, I guess, $30 or less. I prefer to be creative, make your own. After all, it is a kit. Next slide. So this is a picture of what I brought tonight. It shows how the board's mounted. I added a couple of improvements, as I mentioned, to this radio. I even installed an interface for my linear amplifier. Now that may make you guys laugh, but...
Blasphemy!
Well, it's really not a QRP radio. I refer to it as a low power radio. There's no way to adjust the RF output. But it does fall off as a function of frequency. And it's just about QRP levels on 20 meters. And the problem with using this with an amplifier, it's been shown that the transmitter does not really comply with FCC regulations for harmonics. So there's some nasty spikes and spurs here. And obviously, you amplify those as well as the signal when you use a linear amplifier. There are fixes for those, which I will put in. I just did that really just because I could. I really don't plan to use it that way. Next slide. Okay, in this slide, I kind of attempt to show you some of the features I added, some of the wiring. I won't go through this, but I talked about my updates, third-party software, Icon mic, the amplifier interface, the AGC board. I actually added the transmit pop filter, and as I indicated, the next planned update for me or upgrade is going to be this display. And it actually looks like an amazing radio when you put the touchscreen on it. Some folks have actually interfaced it with touchscreens as large as 7 inches. That's pretty amazing. Next slide. These are some of my DX contacts, 20 and 40 meters. So you can see I've worked Spain, Washington State, Slovenia, Belgium, Canary Islands, Croatia. Not bad for 5 watts. Of course, that's a function of antenna and band conditions. And I don't have much of an antenna, but the band was with me. In fact, when I took this radio out to make sure it worked, I put it on the air, and in 15 minutes I worked upstate New York, South Carolina, and Maryland. Just like that. So I guess the band was with me again. Next slide. All right, this is actually my last slide, and what you see here are some informative links. And I encourage anybody who is seriously interested in doing one of these to, you can reach out and contact me. I'll be glad to help in any way I can. The current version is a lot cleaner. You won't need the pop fix. And it does a lot of things better. I think the audio is better from the speaker side of it. Still looks the same. But I guess, Tom, do you put these on your website or what? Okay, so these presentations get uploaded. Okay. You can find me based on my call sign. I'm good in QRZ if you want to reach out to me. Are there any questions? Paul?
On this selectivity, if you added a Putney and a Voltage temperature, or the bottom with the high-end
I'm sorry, I can't hear you.
Either Putney and a Voltage temperature filter on there, or a tie-in or a bottle with the selectivity, but they could have it.
He's talking about the filters.
I'm sorry, I didn't bring my ears tonight, seriously, so I'm having trouble hearing you.
Filters.
Does somebody want to?
Some other sorts of filters.
Oh, you could. You could. In fact, they have added some additional filtering to this radio. There's no shortage of people who are improving it. It's possible. All right, I'm going to go for this gentleman here.
Does the radio out of the box receive AM for like shortwave broadcast stations?
I believe it can receive AM.
Okay. And is there a hack available, like in the firmware, that you could transmit AM?
That I'm not sure.
Okay. But you can receive it for like WWV and stuff
Yes.
like that.
In fact, they strongly recommend you calibrate the radio with WWV.
Right. Okay.
Paul?
Thanks for coming out, Alan. So I'm curious, do you happen to know what the stability of the local oscillator is?
I don't.
Okay.
And I'm not sure if there's actually a spec. But I can tell you that I haven't experienced any drift at all. Once I calibrated it, it's pretty solid. Because that's something that would be most annoying.
Well, it's something that's like required for FT8 and those kinds of things. That's what I was kind of asking.
It may not be stable enough for FT8.
Yeah.
But I know the guys are using it in digital modes.
Another hack opportunity.
Well, I know the guys are using it in digital modes.
Yeah. Okay, that's what I was just curious. Thanks.
So that an opportunity for a temperature-controlled oscillator, right?
Right, exactly.
Okay. Any other questions? Mike?
Yeah, I don't know if it's clear, but the motherboard's completely assembled, and basically the only thing you're doing is connecting the controls to...
That's correct.
To the box and to the...
That's correct. You get header connectors with wires on them that interface with all of the connectors on the motherboard. And most of them are going to the front panel and rear panel. So you really need nothing in the way of wiring to accomplish that, other than what's supplied. And sheet metal work aside or case work aside, you can build this radio in probably 4 to 5 hours, assuming you had a good schematic and knew where to connect everything. And that was kind of one of the pitfalls when I started it. I found there were conflicts, there were wiring errors in the published documentation. That's all been addressed. And so I actually made my own little diagram. That's what I showed in the slide. That was, it said my build. And I found I had to do that to make sure I got it right. Mine worked first time, out of the box. No issues. Everybody hasn't been that lucky. Any other questions? Yes, sir.
Is the receive continuous
Yep.
from like 80 meters up to 30 megahertz?
Yes.
Okay.
I guess one thing I didn't understand was the modes that you operate on with that radio.
Okay, so this definitely does CW, upper and lower sideband, and I believe it does AM, but I'm not sure from a transmit perspective. I know it can receive it, but I'm not sure it will actually transmit AM. Okay, any other questions? Rich?
Is there any provisions or on the drawing board to put tighter filters in there?
Can't say. The manufacturer's not going to do it. But creative individuals could. Any other questions? Yes, sir.
Yeah, how is the CW keying?
Well, I'm not a CW guy, so I really never keyed it.
You haven't used it on CW?
Have not. But it has provisions for a straight key and I guess a paddle,
Okay.
if that helps. Other questions? Okay.
All right, Alan,
All right.
thank you so much.
Well, thank you for having me.